So some of you might not have had this experience, but it's always a lot harder, in my view, to talk to the people where you live and work, rather than going for a day or two trip and then leaving wherever that was. So I took this as a challenge. This issue of heart disease in women is something I've been passionate about, though, for a very long time. And so what I'm hoping to do tonight is to give you a flavor of what we know about differences and similarities in heart disease and in heart health. I hope you come away entertained, enlightened, and hopefully intrigued to hear more about the kind of things that we do here in BioFrontiers. So probably you know the answer to this, that heart disease is the #1 cause of death in the world. And the second one isn't actually very close. And so I'm going to talk a little bit about that. And this might sound like a downer because we're talking about heart disease. But there are some, I think, really hopeful things to learn and some new things. I mean, I can tell you that I learned a bunch of things in preparing this talk for you, and it was really a lot of fun. So here is the deaths in the United States. And you can see heart disease is #1, and all forms of cancer are #2. And then it drops off really quite precipitously. And this looks somewhat similar if you look in the world population, not just in the US. So by heart disease, I'm including a lot of diseases here, syndromes. So it includes stroke, coronary artery disease, and a heart attack, which is an acute thing that happens, and then heart failure, which can result from a heart attack. Heart failure is a chronic disease, and it is the #1 healthcare cost in the United States. And it's been studied, and there's still a lot of questions about how to fix that problem. We know quite a bit about how to help people after heart attacks, not so much about the heart failure. So there are a lot of things that can affect the heart disease. Biological sex is one of them, the chromosomes. Gender, which is known for its lifestyle and behavioral changes. Genetics. Smoking has a huge impact on outcomes of heart disease. Diet can also affect, and exercise or lack of it. And I'm going to talk about some of these things today. So if you look at this, there's good news for people like you who've lived in Colorado for a very, very long time. If you look, what you're looking for is dark red means much more heart disease deaths. The lighter colors mean much less. So Colorado's looking, pretty good here, and then Utah's looking pretty good too here. This is the part of the country where I'm from, which is South Carolina, and the South, as you can see, has huge incidence of deaths due to heart disease. And there are a lot of factors that can contribute to that, multiple ones, even in one person. So I have a question for people in the audience. So do you think that heart disease kills more men than women each year? So if you think that heart disease kills more men, raise your hands. Ah, you're here in this room because you knew the answer to that. And I'm glad to see that we have a heart-aware group here. So heart disease kills more women than men every year, yet most people do not know this. And it's really, really important that if you take home one message here, it will be increase awareness of heart disease in women and its prevalence. So if you break this down by age, you'll see an interesting thing, which is at younger ages, the men die more of heart disease than women. As you get older, however, that switches. And you can see here in the older populations, the women are dying more of heart disease than men. And so why do people not know this in this day and age? I'd say it's really two things. One is awareness of heart disease in women and how things can be differently diagnosed and treated depending on your sex or your gender. And then the biology, because the biology of men and women is really, really very different. And it's a lot more complex than sex hormones. I can tell you that, even though that's a topic for another talk. So as I mentioned, cardiovascular disease is the #1 killer of women, though most people think it's cancer. And more interestingly, in some ways, most women think that most women die of heart disease more than the 7 next biggest causes of death. I mean, 7-fold. It's really pretty amazing. So there was a campaign that was started in 2003, both in Time magazine, which talked about how people should be more aware of heart disease in women. And then there was this campaign, which I've just learned that I think this is the day of the red dress, or the week of the red dress. So the American Heart Association started this campaign called Go Red for Women. And they were urging women to wear red to make this point that women have heart disease. Diet Coke even had a special can of soda that was highlighting heart disease in women. But what's happened since then is a little curious, and I don't have the answer to this, which is why the awareness of women dying of heart disease more than any other thing has declined. So it reached a high sometime after this Go Red for Women campaign, and now it's dropped down to levels that are way less than they were a few years ago. And again, I don't understand the reason for this. So I want to just go through a few things that women with heart disease face. This is kind of a stunning number, that greater than 90% of primary care physicians don't know that heart disease kills more women than men. And that's really bad because that has a lot of downstream consequences. And I'm going to give you a few examples of this. So women with heart disease are less likely than men to be referred to a hospital with similar symptoms, managed by a cardiologist as opposed to only a PCP, aggressively monitored, and treated with effective medications. So all of these things really work against women being able to deal with their heart disease. So here's an exercise that I found. I didn't know about this until recently. So physicians were given 3 scenarios. So they were told nothing about the gender of the people who had the same symptoms. In the second group, gender was identified in the patients. And then in the third group, stress was added to the list of symptoms. And they were then the physicians were asked to say what they would diagnose as heart disease in these 3 different scenarios. So without any gender, it was about 50% said they would diagnose these people as whatever their gender was, these people as having heart disease. When gender was identified, those numbers changed somewhat dramatically. 60% of men, they said, oh yeah, that's heart disease. If they knew they were women, that would drop down to 30%. Same symptoms. If you added stress as one of the symptoms, it stayed the same in men, stayed 60%. But in women, it dropped to 15. I mean, just think about that. That to me was really quite striking. And in case you think that I'm going to tell you that this was in 1950, I'm not. It was in 2008. So this was after the campaigns that were increasing awareness of this. So I got asked a question when I was giving a talk at American Heart probably 15 years ago. We had already started being interested in sex differences in the heart. And somebody in the audience said, you know, this is probably a stupid question, and those are the zingers. Those are the ones that usually get you. And I thought, uh-oh. And this man said, does it matter if you put a female heart into a man for a heart transplant or vice versa? And I had never even thought of that as a question. And so luckily, I was feeling quite confident that probably a lot of people didn't know the answer to that. I said, I bet there's somebody in this room, because there were probably 1,000 to 2,000 people in this room. I said, I bet somebody in this audience knows the answer to that. And so this woman stood up, we've since become friends, and she said, I do know the answer. And I said, so are you going to tell us? And she said, no, I'm going to ask the audience. How many people in the room think it matters? And a bunch of people raised their hand. And how many of the people in the room don't think it matters? A bunch of hands went up. And so it turned out it does matter. So if to make this point, the red is a female heart, the blue is a male heart, and then these little stick figures are the traditional, male-female. So the size of the heart matters. You don't want to put too small a heart or too big a heart into somebody. So if you can deal with the sizes and you figure that out, these are all matched for size. But the hearts that do the most poorly are male hearts into a female. So it would be fascinating to know what that's due to. There's some speculation about what it is, but my point here is that a woman is not a small man, even though sometimes treatments are treated that way. So despite some lack of awareness of the prevalence and importance of heart disease in women, we've learned a lot over the years. And by we, I mean our lab, as well as a number of other labs all over the world. And so we're going to talk about some of these differences today. So pretty much everything we study, we find differences between the sexes. So I'm just giving you a few examples. So I'm going to show you some data about exercise, the cardiac benefits of exercise, heart attack symptoms, high blood pressure responses, genetic heart disease, chemotherapy-induced cardiotoxicity, and drug metabolism. So there are known sex differences in drug metabolism, and this ends up having important implications for the use of medications in women with heart disease. So again, a woman is not a small man. So women metabolize some drugs much more slowly than men do. And what that means is you give the same dose of something to a woman and a man, and you're going to have much higher drug concentrations, which is not always a good thing in women. And so there's been talk for probably a decade or more that biological sex may need to be considered in dosing of many medications, not just cardiovascular ones, but in all types of medications. So I think that it's clear that sex really does matter in the heart. So one thing you want to make sure you do is study both men and women in clinical trials. Here's another stunning fact. Only 18% of people in clinical trials for heart failure are women. Now, that is not good. And there are a lot of reasons that contribute to this, and we could talk about that maybe later, but this needs to be fixed. The second thing is that we and other people study animal models of heart disease. So most of the studies are done in male animals, and there are some not very good reasons for that. So I want to say here that I think you should always be studying, if you can, both males and females. But amazingly, less than a quarter of animal studies actually even report the sex of the animals, or even worse, they actually mix them together, thereby losing a whole lot of potentially useful information. So to conclude this part, heart disease is the #1 killer of both men and women. Public awareness has gotten to be quite poor of this fact, and that women with heart disease are treated very differently than men with heart disease. And clinical research absolutely needs to include more women. So I'm going to show you some interesting movies and a little bit of data. I'm trying to keep this, no equations, no offense to any of the mathematicians in the room, but I think you'll find some of this visually interesting and factually interesting. So think about the fact that your heart is basically a big muscle. And so it beats a huge number of times a day, and then blood travels 12 miles a day. So it's a really, really important pump that you need. And so we can actually measure the differences in that contractility that you saw on that previous slide. And when the animals are young, what we see is that the animals are young, the female heart function is better. And we're trying to figure out what is responsible for that. And then it declines as the animals get older. Also, male hearts are very stiff, which is not a good thing in a heart. And we can measure that here at CU. And I think we ended up doing this with Christy Anseth a long, long time ago. And so we're trying to understand what these differences are due to. So what underlies these differences? So hearts have a whole bunch of different types of cells. The most mass in the heart is the cardiac muscle cell itself. And I'm going to show you just a couple of things about those. So these are heart cells in culture in a dish, in a little plastic dish. And they don't need to be in the heart to beat. which is kind of an amazing thing in and of itself. And this leads us to be able to study these cells in culture, and we can study them from male animals and we can study them from female animals, because these are the cells that make your heart beat. So I'm going to show you a video that I love. So this is actually a heart cell beating. This is actually from a female cell, I found out about an hour ago. And you can measure things, like you can see that the cell is shortening and then lengthening, shortening and lengthening. So we can measure a lot of parameters from these types of videos. And we can see that there are potent sex differences at the cellular level. So I told you that heart function is different between males and females. And now I'm telling you that the cells themselves have very potent differences in them. So we would conclude that female hearts and heart cells beat differently than males. I didn't show you this, but we're dissecting what the components are that might be contributing to those functional differences. So I'm going to talk a little bit about exercise, biological sex, acknowledging that exercise is a lifestyle component to it as well, and the heart. So your heart can get big in a bad way or many bad ways, and it can get bigger in a good way. And what we are showing here is a couch potato, where this person is going to probably have an unhealthy heart. And you can get that because if you have untreated hypertension or you have genetic heart disease, you can get a heart that has an enlargement in a bad way. If you're a highly conditioned athlete, your heart gets bigger also, but in a different way proportionately. You'll see over here you've got a lot of muscle, and here you've got proportional growth of this chamber, what it's called, as well as the muscle. So all this red stuff is all cardiac muscle. So mice choose to run in the laboratory setting on a voluntary cage wheel. And you might notice the astonishing distance. Now, this is not corrected for the short stride length of the mouse. That's an absolute distance that they run, which is extraordinary. And it happens spontaneously. We don't do anything to encourage them to run or to punish them if they don't. So this is voluntary. This is our model of voluntary cage wheel running. So if we ran the same as a mouse does, we'd be running 575K a week. It's really quite remarkable. And rats are kind of lazy. They don't run nearly as much as mice do, which is pretty interesting. But we found a very interesting, unpredicted thing, I would say, which was that females, if you give them access to one of these voluntary wheels, the females run much more than the males do. And again, remember, there's no reward, there's no disincentive. So this is an inherent behavior of these animals. And it doesn't matter whether they're young, whether they're older, they always run more. And we've taken different genetic strains of mice, and the females always run more than the males. And in addition, you remember I showed you that Michael Phelps, I didn't identify him, but that was Michael Phelps on the right, that athletes, human athletes, have enlarged hearts and in a good way. And so we found out that if we measured the cardiac growth, which is a good kind of growth in females, and you took into account the fact that they ran more than their male counterparts, so we normalized per kilometer run, they get a far bigger benefit than do the male animals, which is kind of fascinating. And I've been asked a lot about how this might be translated to humans, so I'm going to give you one example. So this is a woman I had not, frankly, heard of until yesterday, Courtney Dalwalter. So does this have anything to do with humans that we see these female mice running so much? So it turns out that the much newer research has been showing that as the distance of a race lengthens, the gender gap in performance disappears. And she is an amazing example of this. And she has a philosophy and belief, and as do many people, that pain tolerance, no offense to the men in the room, but that pain tolerance is a serious factor in the ability of these women to run faster than the men. So I'm giving you just one example here. So she ran the inaugural Moab 240, and she completed that race in 58 hours. She won the race, and this was being competed in by men and women together. So she completed the race, won it, and the second person in the race who came in second, she beat him by 10 hours. I mean, think about that. This was not a photo finish. So it's quite remarkable. She's run a whole lot of races like this, and apparently she's on the circuit and putting all kinds of podcasts out there. So I do think that there is something here to be learned, that stamina, metabolism, all kinds of things probably integrate to cause this difference between people running these very long races compared to a 5K. So exercise is good for the heart. I know I haven't told you anything you didn't already know. We can study this in the laboratory, and that there are really potent differences, sex differences between exercise and the benefits of exercise, at least in mice, and it appears that this is being backed up by human data. So I'm going to talk about heart disease, sex, and the differences that we see. So I'm going to talk about genetic heart disease. And this is as opposed to lifestyle. So these are people who inherit mutations or have spontaneous mutations, and that has profound effects on their health. So this is a disease that's got a really long name, hypertrophic cardiomyopathy, and I'll tell you what that's about in a minute. But you can see from these three people who have died during a sporting event that it has a very profound effect on both life as well as quality of life. And it's responsible for 30% of sudden death in young people. So a summary of this disease, HCM, hypertrophic cardiomyopathy. So these have mutations that we know about now. The incidence is at least 1 in 500, but probably more like 1 in 250. So there were no approved therapies except for a heart transplant until 2022. And there are profound sex differences. If the people live long enough to be adults, males are diagnosed 7 years earlier than females. So this is another example of a very, very profound sex difference. So it is the most common genetic heart disease. And really all that hypertrophic cardiomyopathy means is a big, sick heart that runs in the family. And so that's the definition of this hypertrophic cardiomyopathy. Here's what a heart looks like. You can see there's a lot of extra muscle in this heart, these heart walls here, compared to a healthy heart. And so that's what the disease looks like at the macroscopic level. So mutations in this motor protein called myosin. So myosin is a protein that makes your heart contract. And this is a cartoon of its interactions with other parts of the muscle cell. And so we can study this protein pretty easily. So how do these mutants cause this disease? So since I showed you a motor acting on the heart apparatus, one obvious hypothesis is that the motor protein is altered in some way. So we can measure a lot of things about myosin. It's one of the best studied proteins in biology, so we have lots of assays that we can throw at it to say, okay, if somebody has this mutation, what's wrong with its motor protein myosin? So here's an assay that was developed by my colleague Jim Spudich at Stanford, and I'm going to show you some movies. And what you're going to see is the orange things are the myosin motors, and then you're going to see these little wormy things that are called actin filaments that are going to be running around on these motors and being driven to move by the motors. And so here's an example. So here's a healthy myosin molecule. You can see you probably don't need a whole lot of graphs to show that this one is moving much more slowly than the one on the right, which could be a mutant in this case. And so you can measure, this is one of those properties of these mutations that you can measure. So it turns out, I'm not going to show you this, but these hypertrophic cardiomyopathy hearts contract with more force than the wild types or the healthy ones. And sometimes people think about mutations as interfering with a function, meaning decreasing it. But I want to make the point here that these hearts are hypercontractile. They contract too much, and too much can be just as bad as too little. And this is a very important part of talking about this disease and how to study it. So our long-term goal was to develop therapeutics that could be used to treat inherited cardiomyopathies. And as I mentioned at the beginning of this part of the talk, that there was no treatment except a heart transplant, and there aren't enough hearts to go around to treat all of these people who have these mutations. So can we treat this disease by slowing down those fast motors? So the ones that are running around a lot faster, can we slow that down and have a rheostat that kind of dials it down? And we did find such a molecule that could do this. And it's otherwise thinking about putting the brake on this motor protein so it doesn't function quite so highly as it does in people with these mutations. So we founded a company in 2012 with John and Cricket Seidman and Jim Sputich. And we went public in 2015. We got acquired by Bristol Myers Squibb in late 2020. And we identified a small molecule that got FDA approved in 2022. So this was really an extraordinary set of events that led to a lot of really interesting and satisfying work. So how does this drug work? I'm not going to get into too many details about this. I am going to use my hands because I like to be sort of physical to show something. And Jack and Jeannie have seen me do this, and I think Jane has as well. So myosin has at least two states, one of which is very active, and that's this one, because this is the motor out here. And then that one on the right is very inactive, because those motors are now sort of tacked on to a different part of the myosin molecule. Now, why is this important? It's important because many of these mutations that cause disease shift the myosin from this low energy state, down here on the right, to a high energy state. And if you burn too much energy in your heart, that's a really bad thing that happens because you have an energy-starved heart that doesn't work very effectively. So our molecule shifts those hyperactive myosins to a more inactive state. And so that's how this drug works. And it becomes very important in thinking about other types of diseases to think about treating, because there are lots and lots of mutations in myosin that cause it and other diseases as well. So I'm going to let you know that we, again, without details, we ran multiple clinical trials, and it has been extraordinarily successful in terms of making people feel better. And more importantly, we had hope that when we developed this drug, that it would stop the progression of the disease, or at least slow it down. But what we didn't anticipate was what I'm going to show you next. So this is my friend Ewan Ashley on the left. He's a cardiologist at Stanford who's been treating people with this drug for pretty much since it went on the market. And so you can read this, but for him to make this quote, he had sent me this selfie, and then I went and looked for some quotes from him. And when he says that he was able to tell this patient in the middle that her disease was actually reversing, you'll notice he said it's the first time in his life he's ever used those words with this disease. So with that, I'm going to stop and take questions and to encourage all of you to be aware and spread this awareness and be curious and ask questions. And thank you.